Hello. Today we will talk about some interesting patterns that we observe in squaring numbers. So the first one is numbers between squares. One example I have taken over here. As you can see, as we know that 3 square is 9 and 4 square is 16, right? How many numbers are there between 9 and 16? 11, 12, 13, 14. Make some space. 15 and 16. So that is 1, 2, 3, 4, 5 and 6 numbers. There are 6 numbers between 3 square and 4 square, and 3 and 4 are consecutive numbers. Okay, so I will write that. So let us say this means that 4 square minus 3 square is equals to 16 minus 9, which is 5. This is one easy trick. This is easy. You simply take the square of the bigger number and subtract the square of the smaller number from it, and you will get to know how many numbers lie between both of them. But we won't be able to do that for extremely larger numbers. So in that case, what should we do? So there is one foolproof trick, very easy trick. Regardless of how big the number will be, we will easily be able to find out how many numbers are there between the squares of two consecutive numbers. So I'm going to say let the smaller number be n, and the next consecutive number will be, therefore the next number will be n plus 1. Now what are we doing over here? Larger number square, which is n plus 1 whole square minus n square. As we know, a plus b whole square, so that's a square plus 2ab plus b square minus n square. N square and n square will get cancelled, and we will get 2n plus 1. So if you want to find out how many numbers are there between the squares of two consecutive numbers, you can simply substitute the value of the smaller number in this n and you will find the answer. Let's check this trick for some other example. Let us say we want to find 4 square and 5 square, the number of how many numbers are there between 4 square and 5 square. So we know that 4 square is equals to 16, 5 square is equals to 25. Okay, if I apply this formula, so by formula what should I get? 2n minus 1, where n is the smaller number. In our case, which one is smaller? 4 is smaller, right? So 2 into 4 plus 1, and that gives me 8 plus 1, and that's 9. Okay, is equals to 9. So there should be 9 numbers between 16 and 25. Let us check if that is true. So 16, 17, 18, 19, 20, 21, 22, 23, 24 and 25. 1, 2, 3, 4, 5, 6, 7, 8, 9. So yes, our formula is correct and what we have learned today works. Okay, let's try for some bigger numbers. Okay, say in the textbook this example is given: 1000 square and 1001 square. 1001 square, big numbers. Ideally you can try for whichever number, but let us substitute this in the formula. Okay, so what are we doing over here? We are finding the number of numbers which will exist between the answer of this square and the answer of this square, right? So the formula is 2n plus 1, and we substitute the smaller number in the place of n. So 2 into 1000 plus 1, which is how much? That is 2000 plus 1, which is equals to 2001. We cannot check if this answer is correct, but from the examples that we have seen and from the formula we have proved, we can say that this is correct. Okay, you can try any number of examples by yourself. Some examples are asked in the textbook, you can go through it. Another property we are going to discuss today is adding odd numbers, addition of odd numbers, adding odd numbers. So what are odd numbers? 1, 3, 5, 7, 9, 11 and so on, right? If I want to add them, let us say I take the first odd number, 1 is 1 plus, there's nothing with it, so 1. If I add 1 plus 3, that gives me 4, which is 2 square. If I add 1 plus 3 plus 5, it will give me 9, which is 3 square. If I add 1 plus 3 plus 5 plus 7, it will give me 16, which is 4 square. And as you go ahead, you will notice that this pattern is teaching us something, it's telling us something. What is it telling us? So 1 is technically 1 square, okay. So if there is only one odd number, which is the first odd number, you will get 1 square, and you have to follow a sequence, okay. The sequence starts at 1. If you add the first two odd numbers, it will give you 2 square. If you add the first 3 odd numbers, it will give you 3 square. If you add the first 4 odd numbers, you will get 4 square. And now can you guess, if you add the first 5 odd numbers plus 9, it will give you 5 square, okay. But this trick is true only if you start adding the numbers from 1 and they should be consecutive. You cannot leave any one number in between, okay. So that is interesting, and this trick is true only for odd numbers, okay. Now suppose if someone is given you a perfect square and they are asking you how many numbers is this square a sum of. For example, if someone says that let's take the number 36, and someone asks you how many odd numbers do you have to add starting from 1 to get 36 as the answer, okay. So you have guessed it right. Obviously you will have to add 6 odd numbers starting from 1. Let us say that will be 1 plus 2 plus 1 plus 3 plus 5 plus 7 plus 9 plus 11, right? That will give you 6 square, which is 36, okay. But if the numbers are bigger and you're not so sure, right, so how do you do it? In the exam, if they ask this question to you and it is for more marks, like more than 2 marks, so how do you explain that? Right? So for that, you simply go on subtracting each odd number one at a time. So 36 minus 1 is 35. 35 minus 3 is 32. 32 minus 5 is 28. Minus 7 is 21. Minus 9 I think I made a mistake probably somewhere over here. This should be 27. Excuse me. Yeah. 27. 27 minus 7 is 20. 20 minus 9. So 20 minus 9 is 11. And 11 minus 11 is 0. So you will keep on doing this till you get 0. And how many numbers did you have to subtract? You had to subtract 6 numbers, and that is how you will get your answer. Now next useful property is that of a very interesting pattern. We have seen a similar pattern in one of the previous videos. I think we spoke about palindromes in the previous video, but this is also another interesting pattern. So if you square 1, you will get 1. If you square 11, you will get 121. If you square 111, you will get 1, 2, 3, 2, 1. If you square 1111, 1, 2, 3, 4, 3, 2, 1. And you can make as many patterns from this as you like. 3, 4. Number of ones over here is 5. So 3, 2, and 1. An interesting pattern. From the things that we have studied just now or discussed just now, there are some questions in the exercise. We will address those questions. We are on exercise 6.1. And so far we have discussed question up till question number 5. Okay. And now we will discuss question number 6. They have given us a pattern in question number 6, and you have to find out the missing numbers. 1 square, 2 square, 3 square is equals to 3 square. I would suggest don't read too much into this. Don't start squaring these. First observe the pattern which they have given. Okay, you never know. Try to keep the work easy. Don't complicate things. Students will right away go ahead and start squaring these numbers and finding their squares. Okay, so first observe the pattern. It's not very difficult. You will clearly see it once you very patiently look at the question. So there is an empty space over here. You have to find the answer for that. Plus again blank. 30 square is equals to 31 square, and 6 square plus 7 square plus blank square is equals to blank square. Okay, let's try and fill these blanks. Look at the first line over here. I can see 1 square, 2 square, 3 square, 4 square, 5 square, 6 square. Okay, that is giving me a pattern. Next I have 2 square, 3 square, 4 square, 5 square, and 7 square. So what will I get over here? 6 square. 3 square, 6 square, 12 square. What is the difference between 3 and 3? 3 and 6 is 3. 6 and 12 is 6. Okay, next I have to find the difference between, so I can see that this is a table of 3. You can say 3 2s is 6, right? And you have to add 9 over here. So 9 and 12, maybe if you add, let us see if we are getting the correct answer. So that will give me 21 square. So no, that's not correct. That cannot be correct. Let me erase that. Let me add. Oh, did I write this question incorrectly? Oh, shoot. This was, sorry, this is 2 square, not 3 square. This is 2 square. Okay. So 4, 2, and the difference between 2 and 6 is 4. 6 and 12 is 6. So clearly, I will have to find the difference, a number which I get after I add 8 to 12. 12 and 8 is 20. So that's 20 square. Okay. Clearly I can see a pattern. 8, so 4, 6, 8 and 10. 20 plus 10 is 30, and I will have to add 12 to 30, so that is 42 square. Looking at the answers, what am I getting? 3 square, 7 square, 13 square, 21, 31. So what will I get over here? Clearly 43 square.